Hello everyone, so it's good to see y'all again. I'm Natasha and welcome back. So today we're going to continue our chapter number 5 and it's complex numbers and quadratic equations. So we'll be soon discussing about the quadratic equations, but before that, in the previous video, we discussed about the modulus of a complex number. And in today's video, I have some questions to discuss with you. So here are some practice questions based on the modulus of a complex number. So we have total 3 questions here, so let's solve them. So let's get started. Okay, so first question is if c is equal to 6 minus 8 iota, then find. Okay, so the modulus of z, the complex number, so mod z. Okay, so the solution is just really easy. So, okay, do you remember what I did in the previous, in the last video? There was I took an example to show that this mod z is greater than 0, right? Greater or smaller? Is it greater or smaller? Of course, I talked that it's going to be greater, but there are some cases in which the mod z is not greater than 0. It's the case when let's say if z is equal to x plus. Okay, let me write it again. Okay, I think it's a little too, I don't know what to say, but yeah. So if z is equal to x plus iota y, okay. So I can say that have you wondered can the modulus or the mod z is equal to 0? Can it be equal to 0? Of course it can be, but there's a case. If z is equal to x plus iota y and x is equal to y and y is equal to 0, then we can say, oh wait a second, I don't think there's any need to use comma, right? Yeah. Okay, so then we can say that the mod z is equal to 0, right? So if x and y is equal to 0, then I can say that the mod z is equal to 0. Or whatever I can say is, okay, so x is saying that if y is going to be equal, y is saying that if x is going to be equal to me, which means that he will have the same value. So I'm just saying that. So x is equal to y, and what's the value of y? 0. So if it's going to be 0 and x will be also 0, so then what we can say is the mod z is equal to 0. Right? Yeah. So let's get back to the question. So what is it? So it is z is equal to 6 minus 8 iota. Okay, one more thing that I took an example, a short example. I hope you have not forgot it. So, okay, so it was 1 plus 2 iota, right? And we had to find the the mod z. So what I did was I put them in the square root and they're 1 square plus 2 square, right? And what did I got? 1 square will be 1. 2 square will be 4. So, okay, wait a second. Yeah, so I had this 1 square plus 2 square, right? It's absolutely right. So under root, 1 square will be 1. And 2 into 2 will be 4, right? So 1 plus 4, which is equal to 5. So root 5 will be our answer, right? Can I say this? I'm not exactly sure about this answer, but But no, I think like through this way, like I solved it. So just by using this way, I'm gonna solve all these 3 questions. So any question will be based, you know, just by like for sure it's going to start from this step, you know, by using the square root, and there are squares too, right? Yeah. So it will be same as it is. So yeah. So what I'm gonna say is it's going to be root 5, so let's get back here. So z is equal to 6 minus 8 iota, okay? So z is equal to 6 minus 8 iota, right? Yeah. And we have to find mod z. Then mod z is equal to, so we'll take it in under root. I was saying loot. No, there's no such word like loot. There's only root. So 6 minus 8 iota. So 6, I'm going to write it here, and 6 square minus will stay as it is, 8 iota. Okay? As iota is not, you know, as the part of, you know, it's not the part of imaginary part. So like, we don't write it, okay? As we all know. So it's going to be 6 square minus 8 square. So 6 square will be, what is it going to be? It's going to be 36, right? Yeah. 36. And 36 minus 8 square will be 64. Okay, yeah, it's actually going to be 64. So what is it going to be equal to? Okay, so this 36 minus 64. So if I'm going to, you know, just subtract them, then it's going to be... Okay, I'm just trying it here, okay? Yeah. So, 7, 8, 9, 10, 11, 12, 13, 14. So, like, there's total 8, right? 8 plus 6 will give us 14, right? And now there's 5 here, okay? So, 5 minus 3 will give us, what is it going to give us? It's going to give us 2, 28. So, root 28. And, okay, so just have a look. Is it correct? Like, do you really think that we should do it this way? How many of you think that we should do it this way? Okay. One thing we always know is that we're always going to use this plus sign. Because, you know, like I told you that this x plus iota y and x minus iota y will give us x squared plus y squared. So like plus cannot be replaced as minus. So it will be minus here, but it's going to be plus actually, because that we're adding them, right? So, you know, through these some small mistakes, like we can do this usually. So I just solved it to like I just wanted to see like how many of you will believe this. Okay, so it's 6 squared plus minus 8 squared, okay? I think it's fine. Yeah. So now this minus 8 squared will be in positive, right? Okay, so what is it going to be? 64. Okay, 6 squared will be, guess what is it going to be? 6 squared will be 36, right? And this positive 64 plus 64. Okay, so what is it going to be? So this will give us 36 plus 64 will give us 100, and root 100 will be 10, right? So this is the correct way, and we'll never subtract any of the equations or whatever like they're given to us. Whatever the questions, you know, whatever I can say this equation or kind of complex number sign or like whatever we have to find is that all that matters is we have to find a modulus, and we're always going to add them, okay? Even if they're going to have the negative sign, that doesn't mean, okay? We're actually going to add them because that, you know, that's like basically in the rule. Okay, so is this clear? So the answer is going to be 10. So let's solve this second question. they're like, all these questions are really easy, so why don't we, just solve them fastly, okay? So z is equal to, okay, so we can see that here we're having a root 7 iota. That doesn't even matter, okay? So z is equal to 3 minus, okay, minus is again there, so is again here, okay. Root 7 iota, okay, so then mod z is going to be, can you just do like a guess the answer just by, like without doing any calculations or anything, nothing else, like just guess it. What is it going to be? Okay, so we're going to do it like just like this way. So it's going to be under root 3 plus, and in the, in brackets, going to be negative root 7 squared. Don't forget the squares, okay? Is equal to what? So 3 squared will be, what is it going to be? 9. Okay, and root, don't forget it. Okay, so negative, which is going to be positive, so root 7 squared will give us root 49. Right? Yeah. Root 49. Okay, so how about I, write the answer? How about I write the answer? Okay, wait a second. Okay, I'm gonna just continue. So, like, I should tell you in the detail, like, we should discuss this in each detail. So I'm gonna write this. Okay, so we have this 9 plus root 49. So we can write this root 49 as 7, right? Yeah. So it's going to be root 9 plus 7. And 9 plus 7 will give us 16. And root 16 is equal to 4. See, we're like totally a piece of cake. Like we haven't finished the cake, but whatever. So the answer is 4. And we're going to solve the second, we've already done the second question. So we're going to do this third question. Okay? Yeah. Okay, so it's kind of different from these two questions. So, but yeah. There's nothing hard in it. It's just an easy question. So let's solve it. Okay, so what is it? So we have to find the mod of this complex number. So it's 2 plus iota and by negative 1 plus 2 iota. Okay, so first of all, don't remember the square thing. So it's going to be 2 iota mod 2 iota by mod negative 1 plus 2 iota. Okay, I've just separated there, modulus, so the mods. And next thing is, what is it going to be? We're going to write it in under root, which is going to be 2 squared plus 1 squared. Oh, did you really forget the 1 here, which is actually not mentioned here, but it is 1 iota, right? Yeah. So 1 square, and in the denominator, yeah, one thing that in the denominator is not equal to 0. So it'll never be equal to 0. Actually, it's the part of a property, and we're going to discuss that property too. Oh, yeah, that will come in the properties of modulus of a complex number, and we'll discuss it soon, but okay, what are we waiting for? Let's solve it. Okay, so let's finish it. So it's negative 1 plus 2 iota, right? So I'm going to write it like this way. Negative 1 square plus 2 square. Okay, I hope this is clear. So 2 squared plus 1 squared. Okay, 2 squared will give us, what is it going to give us according to this one? It's the same case, right? Okay, so 2 squared will be 4. 1 squared will be, what is it going to be? 1, of course. So 4 plus 1 will give us 5. So root 5 by. Okay, so the next thing is 2 squared. Negative 1 squared will be positive 1, right? Yeah. So positive 1 squared will be 1 and 2 squared, again 4. So what I'm going to have is same exactly. Oh my gosh, I got the answer 1. It's really easy. What we're going to do in the last, we'll cancel it and we'll get 1. Yeah, let me tell you that it's a property in, z1 by z2 is equal to z. Oh, wait a second. Oops. Okay. I think there's I can just, clean this from my hand. Yeah. So the mod, remember the mod, okay? Don't forget the mod. So mod z1 by z2 is equal to the mod z1 by z2. Okay, so this is like clear, but one thing, that z2 is not equal to 0. Okay, so this is what we can say, right? So this is a property. So like there's no need to write this. So the only thing that we have to see here is that the z2, which we're having, in the denominator is not equal to 0. So one thing that we have to just remember, z2 is not equal to 0. And will never be equal to 0. Okay, so just by canceling it, I got the answer 1. And we have solved all the 3 questions. It was quite a lot of fun, right? Okay, so I hope you enjoyed. So, that's all for today. In the next video, I don't know what we'll be discussing, maybe the properties, of this topic, or we can discuss about something else. So, thanks for watching and have a great day.